But now we're going to talk about the future of space cybersecurity education. So move on with the same topic, but look at how really the universities and the industry can come together so that universities teach what the industry needs. So please welcome onto the stage Elise Guerra Monasterio from Space Estonia, Crouse from Embry-Riddle Aeronautical University, Adrian Venables from TalTech, and Janis Dalbinš from the University of Tartu. So the standard has been set really high this morning. I'm sure you're going to continue exactly with the same energy. Go ahead.
Thank you. Good morning, everyone. My name is Elise. I'm a project manager in Space Estonia. And last year, I was involved with drafting the vision for Estonian space education, which addresses the need for development of space cybersecurity education. And yesterday, in the first panel yesterday, it was confirmed, and we heard that experienced personnel is one of the biggest non-cyber problems in cybersecurity. And in this panel here today, we have the opportunity to discuss space cybersecurity education and how we can keep pace with this rapidly evolving domain. And I have with me 3 panelists from 3 different universities. And I would like to start with introductions. So could you all just introduce yourself shortly and add what inspired you to address space cybersecurity in your institutions? And if you will, you can add which movie best represents your view for the future of space education.
Thank you very much for inviting me to speak on this panel today. My name is Crouse. I'm the Associate Director for the Center for Aerospace Resilient Systems, as well as the Associate or Assistant Professor of Graduate Studies and the Program Coordinator for the Space Operations Program at Embry-Riddle. My university really prioritizes this. Our president's vision, one of his #1 strategic priorities is cybersecurity in aviation and aerospace. So he's charged several of us, especially with the Center for Aerospace Resilient Systems, on improving cybersecurity resiliency throughout the domains. And then also my background in Army Space Command, working with satellite systems and then moving into cybersecurity gives me that cross-discipline on understanding the different threat vectors that are out there and why we actually need to secure it. As for the movie, I would actually go to a TV show, The Orville by Seth MacFarlane. It really highlights several different things, especially with AI compromise, autonomy, and cross-discipline learning in order to really be able to handle the threats as they come at you. So.
Good morning, everybody. My name is Adrian Venables, and I'm the manager of the Cybersecurity Master's Program at the Italian University of Technology and the self-appointed head of TalTech's Space Center. TalTech is moving into space cybersecurity for 2 reasons, really. Firstly, we can thank Elise for that, inviting me to a meeting last year in which the European Space Agency said, we recognize cybersecurity in space is a thing and we need help, at which point the Estonian Space Office has said, we do cybersecurity really well in Estonia because we get lots of practice from our neighbor, and therefore it's a really good idea that we get involved in space. And Adrian, you do the cybersecurity masters, over to you. So I took that mantle on. And the second reason is there are 143 cybersecurity masters programs in Europe. So why would anyone want to come to the top right-hand corner of Europe to study? Well, now we are offering a specialist module in space cybersecurity, which sets us apart, and we're going to be unique in doing that in our master's program. And so we will attract students from Europe and beyond to study cybersecurity with this specialization in space. And the third question about a film, I'm looking around, and I don't think anybody here, maybe 1 or 2 exceptions, was around to see when the film first was released, way back in 1968. Danger. But if you think about 2001 Space Odyssey, which was and is a fantastic film, which was about space exploration and rogue AI. So the ability to predict the future way back then, and it's still a very current film in terms of AI and space and security now. So that's the film which I would thoroughly recommend you see, because it is a superb piece of cinema art.
Okay, hello. My name is Janis Dalbinš. I'm engineer in University of Tartu in Tartu Observatory. I was one of the people who built SCUBE-2, and now I'm working on other space missions like OPIC instrument for ESA Comet Interceptor. And the reason why I started looking into cybersecurity for space was mainly more like reactive, because while building a satellite, you want to build the thing, but quite often you need to figure out what is the most important, and quite often we were not really wanting to move into the security part, because it's always easier to say, oh yeah, there is the distance, not everyone has ground stations, but the more you think about it, it starts to change quite a lot. And I think we need to be very proactive and start building this competency locally between our engineers and developers and of course students. So therefore, I believe like it's very important for us to take this step and work on space education. Space cybersecurity education. And regarding a film, I would move to the series. Quite often, maybe people sometimes ask about why do you need education, about these specific topics, I will never use it, sort of a thing. And I like to draw parallels with a series called Expanse, where one party like Mars becomes way more evolved in technological sense, and then they can become either a bad actor or someone can take their technology to use for bad things. So I think we could be in the same situation with space assets. Like if we build something and then some bad actor can take it over, then we lose our asset, and we definitely don't want to be in this situation.
Thank you. You mentioned engineers, and we're going to talk a little bit about how cross-disciplinary should space cybersecurity education be. What's the one thing that you wish every engineer would know about cybersecurity and vice versa? And are there any common misconceptions perhaps out there? Perhaps you've heard something during the conference that you would like to break? Like
from what I have heard the most, it's always that there is this air gap. Satellite is 500, 600, geostationary satellites are 30,000 kilometers away, more, but like there's always this saying that, oh yeah, it's so far away, it's so difficult to achieve actual communication or approach them in this sort of a way, but it's not a case, in my opinion, anymore, because, well, as an engineer, I would like to build a satellite with less complexity as possible. So, for example, I maybe would not want to use a ground station on Earth, but use these amazing new satellite constellations that provide internet access and then directly connect to an internet network, and then my satellite becomes basically part of internet, and then anyone can access it. So then, I made my access easier, maybe even cheaper in that way, but also then the problem becomes the other way around as well, that everyone can have an access now, and then we need to work on that and improve on it. It's similar like it was in like 90s and 2000s with antivirus software. Like nobody liked it. It ate up all the performance of the computer, but well, we kind of need it. So I think it's the time for satellites to do the same.
Adrian, would you like to add something?
Well, from my perspective, teaching the next generation of cybersecurity managers, we need to prepare people to be able to work in the space industry. And so my course is now developing these modules to enable cybersecurity professionals to understand the unique attributes of the space domain and to be able to communicate with space engineers in a language that they understand. Because currently you see the engineers and the cybersecurity specialists, they are adversaries in that the engineer goes, oh, cybersecurity, that's a processing overhead, that's a memory overhead, it's all a nuisance, I don't really want it because it makes my life more complicated. And the cybersecurity specialist is saying, yes, but these satellites need to be designed with security in mind from the start, and we need to understand the threats and the vulnerabilities. So if we can get these two groups to talk the same language, then they can work together from the beginning. This is very much a case of computing 10, 15, 20 years ago, as Janis was saying, in which security was plugged in at the end. Now we need to think about space, the space domain, satellites, ground stations, communications, and think about security from the start with these two groups of people working together in unison with a common aim.
Yeah, and I'll just echo what both of them said. For the longest time, everyone's viewed cybersecurity really just as compliance checks instead of mission assurance essentials. So I think once we get that over that hump of just checking the box to make sure that you're compliant with the regulations and that it's really baked in from the start, we can actually move to the understanding that we really need to secure not only the space segment, but the ground segment, the link segment, and then the user segment as well.
That's good. Coming back to the panel yesterday and talking about expertise, competences, how can universities better align their programs with the needs in the industry? And what are perhaps the core competences that should be in the space cybersecurity curriculum or should be addressed? Can go start from here.
I'd love to start on this one. So the first thing that they do is partner with industry to understand their needs. Agencies like ISACs and stuff, the Space ISAC, there's both the US and the European one, embedding in those groups, talking to them to understand their needs and develop curriculum based upon those, have different modular assignments that can be changed rapidly because the space moves at a blazing speed, right? So stuff that I knew last week isn't relevant today because of how fast things are moving. And then one of the biggest things from every student that I've ever talked to about how I should be developing my courses is applied learning. Most cybersecurity courses are really taught in a theoretical sense. So actually getting hands-on experience through things like the CR14 or different virtual machines that you could develop, Raspberry Pi systems, software-defined radios, anything like that, to actually show them how it functions in an operational setting will, I think, really help understand, have mission-capable students ready to move into industry.
I don't think we in academia and education, we can't teach everybody everything they need to know in all environments. I think part of our role is to give a foundational knowledge and then to inspire and inform and encourage the students to take their own path and to have the skills that are required. So the research skills, the educational skills, knowing where to go to be able to progress their own careers in their own environment. I think that's absolutely key. So I'm delighted to see several of my students here today. Hopefully that's because I've inspired them and not intimidated them to be here, or they will fail. So they are here, so hopefully we're doing the right thing. But we need to have the students understand that space cybersecurity is a thing, know that they can be trained to a certain extent to know really where the gaps are, the sort of the known, unknown elements, and then to proceed their careers suitably encouraged and inspired.
I think one of the challenges definitely is this ever-evolving field of cybersecurity, as it was mentioned also in previous panel as well, about how methods of dealing with these things can change. But I think the best way how you can learn is by this practical approach on exercises and things in this sort of way. So that's one of the reasons why I'm trying to make a course which would focus on not only just showing, okay, these are the methods, that they exist and it all, now be afraid, but also try to do it yourself to see how does it work, how do you approach this problem, because when you build your own system, like a new satellite or any kind of new space mission, like let's say, moon rover, what we are doing also in Tartu Observatory, it becomes much more easier for the students to see, oh yeah, this is actually a problem. We quickly created this access point, and then it's all unsecure, so everyone can access it actually if you know how to do it. So let's not do that. So they already know this from the get-go. So they start and add these security measures before they even started running the system. So I think that's very important to give practical experience, and then they can immediately try to apply it.
Talking about practical experience, do you have some good examples that you could bring of testbed simulation environments? How do you offer this hands-on practical experience to students in some more concrete examples? Can start from here.
So we're deploying several different VMs that are based on NASA software through Amazon Cloud that will have students be able to interact with the ground segment, the link segment, as well as the space segment, be able to do defense mechanisms, but also do red teaming on it to try to do pen testing to see where the vulnerabilities lie, and then take that application to actually applying it to like risk management framework and being able to set your priorities and budget correctly in order to mitigate what is most vulnerable.
I think one of the great strengths of Estonia being a small country is that essentially everyone in the space industry in Estonia, we all know each other. And that's why these conferences are so important. It's like a family reunion in which you can get so much business done because you have a list of people you want to talk to and you know that they are all going to be here at some point. And of course, being a small country, here we have Tartu, only a couple of hours down the road. Here in Tallinn, you've got TalTech, you've got the Space Cyber Range, and you've got the Student Satellite Program. So essentially, you have everything that you need in one ecosystem, all fairly close together, to give the practical applications. So one of the key things that I'm trying to do is to draw all these different elements together. And so we have the practical application with the Student Satellite Program to get young people involved in creating the satellites, and then as a spin-off, we can get universities to develop the digital twins and the flatsats and have the technical experience and learning environment there. And then hopefully in the Space Cyber Range in due course, we can develop space cybersecurity exercises. So Estonia will become a one-stop shop for space cybersecurity, hopefully for Europe and for this part of the world, with our collaboration with our American colleagues who are looking at the similar subject on the other side of the Atlantic. So really, it is our job with Estonia to work together to take over the space cybersecurity sort of center of gravity for the EU.
I think from the practical perspective, I think Student Satellite Foundation is doing a job that no one really tries to do anymore in like student environment, which is build satellites from scratch, because quite often a lot of student projects are just buy in components, assemble them, write a little bit of software, and then shoot it in space. And we are trying to give them an opportunity to learn from ground up to the end of the process. But I think from the perspective of how practical can change students, I think I'm one example is that I got very much inspired and like changed in a way from last year's conference when I took a part in this Capture the Flag event, where most of the people were cybersecurity people, and then they were struggling with what is orbit. You know, what is an orbit thing? Why can't I connect to a satellite now? Why do I have to wait like 90 or 60 minutes or and so on? And it was like very obvious for me. But the other way around, I was like, oh, I would like to do these exercises which are connected to space, but I can't because I can't really reach or overcome the simplest things in cybersecurity. So I think that's what I want to show our students, and I think something similar Adrian should show their students, that there is both sides and they need to be practically exposed and slightly tortured.
Mm-hmm. You talked about the simplest things in the cybersecurity, but cybersecurity is also a very rapidly evolving domain. There are there are new threats all the time. How do you keep up with your curriculums, with the new threats? What are the perhaps biggest threats out there today, and how do you keep up with the landscape and the constantly evolving landscape of cybersecurity and the threats out there?
By staying in literature nonstop. So the majority of my reading now is just reading research and news articles related around space items. One thing that I'm looking to do is the modular curriculum where as I get updates, I can just start injecting it into my courses. My courses are updated every single semester to reflect the most pressing threats. I think right now the largest threat landscape that we have to look at is the ground station compromise. I think everyone is well aware of it. We talked about it yesterday and several different things. And then supply chain is also a huge risk factor as well, and where you source your parts from. My students, one of the clubs that I advise, they're building satellite systems, and when they look for vendors, I'm like, you can't use certain countries to buy their parts because then they could all automatically be compromised just by the way that, especially in the United States, we have much more restrictions on who we can actually buy parts from and everything. So, but yeah, I think the biggest thing is just making sure that you always stay updated on the constant areas. I'm involved in the Aviation ISAC, which allows me to really get ingrained into the community, understand the current threats that are going on at different TLP levels, and then I can talk one-on-one with industry advisors as well to figure out where I should be shaping my curriculum, what updates I should make to it as well.
Mm-hmm.
To start with, I would agree about the range of threats. I think the adversaries which we all recognise, the big four, which we always talk about of Russia, China, North Korea, and Iran, they are increasingly working together against us. Chinese satellites are over Ukraine at the same time that Russia is launching attacks into Ukraine. So our adversaries are talking, and as a result, they are more of a threat than ever before. And so to counter that, we need to work together because we are better, stronger than apart. So here we have the three universities here. We have a link with Embry-Riddle. Last week I was in Tartu looking at how we can collaborate. So I think we should be working together a lot more and playing to our strengths. We shouldn't be duplicating work. We should be understanding where we can divide and excel in our own particular areas, because our adversaries are talking to each other and we need to do it as well. And we need to be under no doubt as to the risks, the uncertainties, and the threats of the future in the space domain, and work together to counter those.
Well, as Sean mentioned, academia, and Adrian mentioned military as a source of information. I think also industry could help us to stay up to date because, well, they are dealing with these problems as well and have to create solutions and so on. But not only just cybersecurity industry, because quite often, like, vulnerabilities come from multiple angles. So we should approach multiple different industries, just regular software development, hardware development, and ask them how these new technologies that we are now putting in our satellites, how they can be influenced and hacked and so on, because quite often it's quite nice to put the nicest, newest chip in your satellite, but like if it has many vulnerabilities that you don't know even about or even know that they might exist, then I think you should contact industry and ask what have you seen, what kind of problems are there?
Mm-hmm. Adrian mentioned that we need to work together. Going more to the global collaboration side, today we're more connected, but we're also more autonomous at the same time. What kind of challenges does this pose to cybersecurity education? Adrian, maybe you want to start.
Yes, I think collaboration is absolutely a key. We have this working with Embry-Riddle, and there's a cyber rodeo next February. If you're interested in going to Florida, in February. I'm going to do the plug for you now. Interested in going to Florida in February, and believe me, Florida is nicer in February than Estonia is in February. But there's an opportunity to meet essentially the American counterparts to the group here in Estonia, and to learn from them and play to their strengths as well. It's great to see Sean here twice within 6 months, which shows the willingness and the dedication of the American colleagues, the recognition of the importance that Estonia is in the space cybersecurity domain, and the investment to work together to be stronger together.
Sean.
Yeah, so just want to thank you for that plug. The part of the ACI Cyber Rodeo is also a big capture the flag activity. So you can send out your pen testers, come out. It's aviation and aerospace focused, so there'll be a lot of aviation-based attacks as well as satellite missions. TalTech is going to actually bring out a CTF activity focused on space that's going to be part of it. You can compete in teams of 3, and there's going to be up to $10,000 in cash prizes for anyone who comes to participate. So really want to get y'all out there. I see a bunch of students just lit up when I said that $10,000. So hopefully we can get more of y'all out there. And I'll give a plug to the students. If any companies want to sponsor some student teams, feel free to reach out to Adrian to get some more students involved in that. So, but I think one of the biggest challenges for collaboration is really with export control, data sensitivity. I'm the PI for the FAA Cybersecurity Data Science Project. We worked with a lot of airlines to detect cyber anomalies using AI ML processes, but for some reason, airlines didn't want to give us an airplane. They didn't want to give us their architectures. So what we had to do was create a digital twin of a generic aircraft based upon the current standards that are out there. And then as soon as we started doing that, airlines were like, oh, that's not quite right. This is how we do it. And then we have this really high fidelity digital twin environment that we can actually use it for cyber attacks. We use it internationally. And we've actually updated several of the standards for aviation cybersecurity with that in mind through those collaborative processes.
I think in our environment, not just in Tartu Observatory, but also in Student Satellite Foundation, we have tried to collaborate a lot internationally, and it's always difficult to keep the collaboration ongoing because, well, we're not a company, we are not for profit, so if we can't provide a service immediately, maybe, yeah, it's difficult to keep it ongoing, but I think, yeah, collaboration with TalTech and hopefully with Embry-Riddle can bring us more together and make students interact with new environments so they can see new perspectives and hopefully build something new out of it. Because, well, I assume when American students would come here, they would be very surprised about how we live our lives here in comparison, well, also vice versa then.
Yeah, we're collaborating. The Student Satellite Club is in collaboration with my small sat club at our university, and I'm planning on sending out 2 students in July to actually embed with your team for a week to actually start working on that international collaboration, so we can share lessons learned between U.S. and our European partners.
Yes.
That's good. Janis, if you had unlimited budget and no bureaucracy, what's the first thing you would build for your space cybersecurity course?
So I would build more flat sets. We have already one of S-Cube 2, but what I would want to do is to put as many devices around it, meaning as many ways how to try to destroy that satellite. Because we can very easily rebuild it because we know how to make it, but quite often lots of vulnerabilities can be found with very specialized tooling, which often costs more than a new Ferrari. So I think that would be one of the ways how I would spend the money, is try to get as many amazing engineering tools and use them to attack the satellite.
I know you want to.
It would be lovely to have a constellation of our own satellites flying around that would enable the students to use our university ground stations to actually connect to the satellites and do capture the flag exercises on a live satellite in orbit, so that they can see that they don't have access to it continually, and to be able to say, yes, we have our own satellites that we can practice on. That would be fantastic.
Yeah, I was going to say basically the same thing, except I would add every different type of orbital parameter in there, so students can really see the difference between securing different types of satellites at different inclinations, altitudes, and orbits.
Mm-hmm. Is there anything else you would like to add? What can US learn from Europe, or Europe learn from the US when it comes to the approach of how we teach space cybersecurity and so on?
I think understanding both standard bodies between, the US really focuses more on the NIST standards, while European, EASA, or I don't know if that's the main standard, or the ISO stuff. So just understanding the different requirements as you build out your satellites from the different countries' aspects, and then what that actually means when you get to operational. Because if you have a multinational team working on a satellite system, they need to understand everything from all sides of it versus just a lot of people are pigeonholed in their own country's knowledge base instead of expanding it to do global collaboration.
I think from my perspective, engagement with industry is really important. I always say to my lecturers two things. Are we delivering the product right, and are we delivering the right product? So is our teaching of the right standard, and are we teaching students who are able to move into the industry with the right skills? So that engagement with industry, to actually ask you, the industry, what do you want from our graduates, so that we are delivering the people who you can employ. I think that's absolutely key. So establishing those industry relations are really key. So come and see us and introduce yourself to us, and then come and see what we're doing, examine our curriculum, examine our programs, and say, yeah, that's fine, but I want you to teach that, because that's what we need.
And you answered also the question from the public right now, which was about how you say we want to work more closely with industry. How can we make this happen? And this is how you...
Conferences such as this are absolutely key. To be able to recognize who is here from academia, who is here from industry, and to come and talk to us and check that that we're doing the right thing, and we can come and see you. You can come and see us, and that engagement. I mean, we're not a big country. It's not that far to go anywhere.
Also engaging with companies in trusted spaces. A lot of companies have a lot of proprietary stuff that they don't want to, share out into the public, especially if you put it in academia where we're nonprofit and we really just teach, right? If we get proprietary information, how can we make sure that we're not compromising intellectual property in our teaching while still understanding the specific nuances on different things that we need to address in those areas. So agencies like the ISACs and stuff create those safe environments where you can actually share the stuff. And then getting more involved into the CTF activities. Again, going back to my event, if any companies would like to actually bring an event and actually add something to the capture the flag exercise, please come see me. I'd be happy to talk to you about what that means. We are a nonprofit. We fund this locally from our internal budget, so we don't have any budget to bring people out. It is a little bit expensive coming out to the States, but it's well worth it. Last year we had about 350 people, 11 different universities. This year it's going to, the projections over 500 people with about 20 to 25 different universities coming out. Also gives a really good talent pipeline that industry can use to come and look at students, see what their current skills are, and then use that to give feedback to the programs that are actually trying to work on this solution to be able to improve our education programs to meet the needs of industry.
Mm-hmm.
I think I could add quickly on the point of to some extent, Europe and America is also not that different, even though we might have different standardization bodies. They more or less are the same, very similar. For example, what I want to say is that like we need to expose students to this sort of an environment, because that's when they go into the job, like an engineering job market, they will have to deal with this either way. So they would be already exposed to this and know, okay, this is a normal thing. I have already seen many of these things, and it's not overwhelming immediately. And we should make them also much more attractive for a potential employer. Because, like, for example, a very common engineering standard is CCSDS, which is used for communications and standardization of how do you communicate in general. And if you know about this, you can already learn what does it consist of. And for example, then you can already start listening to satellites. And at the end, you see, okay, they are not encrypted. You can already see their video streams from like space, from the Starship. And you could see things that you know, the company itself doesn't want to know. So immediately you gain this sort of a knowledge and know-how that's very attractable also then for not only for yourself but also for your future.
Tapping once more into the skills, we have a question from the public. What's the direction or advice you could give to the next generation coming through education? Do they focus on coding or AI wrangling, for example? AI wrangling.
I know I do a big focus on how to use AI ethically in all of my classes, show them how they can use different LLMs to actually improve their knowledge base, but not specifically having the LLM do everything for them, because you still need to do fact checks, you still need to make sure you understand what the information is coming out. Subject matter expertise in the domain is very critical. Coding, from everything that I read, is going to be completely done by AI within the next 5 years. But you're still going to need to have that coding knowledge to be able to go in and do checks on it. Especially if you want to develop like your own internal stuff, it's probably much better just to learn how to code to be able to set those up versus, especially in a work environment, they're going to want you to actually have those coding skills versus being able to just use AI to get code.
I would absolutely agree with Sean on the case of core skills. So I would focus more on the coding element so we understand what the AI is delivering. I think the younger generation, the next generation of students coming through, I don't think that I need to teach them anything about AI. I think as they grow up, they are learning it. Each year when I do the admissions tests and the admissions interviews, I ask for a motivation letter. And I get students from Africa, from India, from the UK, and from America. It's funny, they all deliver exactly the same motivation letter. It's almost as if they go to ChatGPT and say, write me a motivation letter to go to TalTech to do cybersecurity. So I don't think we need to teach them prompt engineering. I think they know that. But when we ask AI to deliver code, we need to be able to have the skills to be able to check it and understand what is being delivered.
And make it more efficient for space systems.
Yeah.
I think AI is a tool. It's not currently definitely just a tool that you can use to help either accelerate your work or do things that you are not so good at, like grammar, for example. But from the perspective of coding, I think whenever you ask either any of the AI tools to give you a code, I think everyone should learn how to understand what it has given you. Like as it has been mentioned, to understand what's the function, like how can you actually use it for your own benefit, not just use the existing parameters and then just roll with it, but how to then approach this generation and then use it for your own needs. Because like when I ask for some example code, it always gives me something, but then I need to then actually understand what it really does. And I think that's very important for next students, is to understand what the functions in code do before they actually use them in something permanent.
Mm-hmm. Considering major players in space cybersecurity primarily focus on hardware, how can we ensure software developers and engineers take active participation in improving space cybersecurity? Another question from the public. So how can we ensure that software developers and engineers take active participation in improving space cybersecurity?
I think Adrian already mentioned about management, because quite often, including in our team, students just want to do what they want to do, and sometimes you need to show them, okay, there are things that you need to do because they are important, and sadly you kind of have to scare them with bad cases to prove your point. That you know, like, let's say I can show you how to hack your feature, that it will be used against you, and what you're gonna do then. So I think it's important to kind of show them that there is a consequences if you don't focus on these specific problems.
I think part of the solution is in terms of terminology. If you regard cybersecurity as actually cybersecurity engineering and make it more of an engineering discipline in terms of both hardware and software, then engineers who would think of themselves more as developing things will actually think, well, actually cybersecurity is part of an engineering discipline, and they may be persuaded to move into that area more.
Yeah, it should really be involved in the entire system design from start to finish. The software engineers need to understand their hardware so they know the capabilities, limitations, and be able to link that to their software development and cybersecurity to understand the vulnerabilities that exist if something goes on that piece of hardware, and how to actually really develop it to prevent any of that thing and improve the resiliency of it. And also, there needs to be more focused on zero trust design right now, which I haven't heard that talk too much. It's a big push in the United States right now. But moving into that zero trust architecture where you assume everything is compromised will also, I think, help everybody from the hardware to the software to the engineers really create a more safe and resilient environment.
Mm-hmm. So to really wrap it up, the space cybersecurity education really needs to be considering cross-disciplinary aspects. We need global collaboration to offer the best possible experience to students, best examples, and that the training needs to reflect the real world out there and what is going on. It needs to be up to date, and space cybersecurity is no longer a niche, it's foundational. Do you want to not lose the opportunity to why should people come to study in your program? Opportunity to promote.
If you like a beach and warm weather, my program is great. So one thing I really tell a lot of students who come from engineering backgrounds is some of the best engineers I've ever worked with have an engineering and an operational understanding of things. My program is focused on operational aspects of things, and a lot of the engineers miss the whole human factor aspect of things. So we actually start introducing them to the human factor aspect to really be able to engineer for humans instead of just engineering to engineer.
I think from my perspective, is a case of come and study cybersecurity here in Estonia because we have everything that's needed. We have the program, TalTech has a ground station, Tartu has the observatory, the Student Satellite Foundation, the Space Cyber Range. Everything is here, and we all know each other, and we can talk to each other, and it's a fantastic opportunity for a student to be exposed to everything they need to know to move into the space cybersecurity industry.
Well, I would do the polar opposite of Sean. We have nice winters. Like the view from observatory is amazing. So, but from the perspective of knowledge and learning, it's important, to get the practical experience, which we have plenty of opportunities for our students, as there are many space-related activities. And I think it's very important to not only invite new young students, but also existing engineers, because as everyone knows, the mother of all knowledge is repetition. So, if you studied cybersecurity 10 years ago, it doesn't matter. Everything has changed. So I think people need to renew their knowledge and do it more.
Very good. Thank you very much. We have 2 seconds left. Thank you.